Good evening everyone, myself Hetvi Bhuva and I am from FYBPT. Today we are going to learn about the force and motion in human body. Force and motion are the fundamental concept of biomechanics. It applies the law of physics and mechanics to the human body to understand the movement, posture, balance and the force acting on the body tissue. First, when we heard about the word force, what do we actually mean by a force? A force is a push or a pull of an object as a result of its interaction with another object. There are mainly four characteristics of a force: direction, magnitude, line of application and a point of action. Now, when we talk about the word motion, what do we mean by motion? A motion is a change in a position of a body or a body segment over a time. So, the content which we are going to learn in this video is the types of force in human body, types of motion in human body, Newton's law of motion. Now, as we have learned the definition of force, in short, we can say that a force is a push or a pull of an object. But in physics, we can say that force has the interaction between two or more bodies. A force only acts on a human body if it is explicitly applied to the body of another body or an object. Now, when we talk about the force on a human body, there are many types of force, but the force which acts on a human body are of two types: external force and internal force. External force means the force which acts on the body from outside, while internal force which is produced within the body. There are mainly four types of internal force: muscular force, ligament force, tendon force and a joint reaction force. There are mainly five types of external force: gravitational force, friction force, applied force, magnetic force and air resistive force. So now, external force. First, gravitational force. By the definition, we can say that every object on the earth experiences a gravitational force which acts downwards towards the center of gravity of the earth. It is exerted by the earth on the body, acts vertically downwards through COG. The force of gravity is always equal to the weight of the object. By equation, we can say that Fg is equal to m into g, while m is equal to mass in kg and g is equal to 9.8 Newton per kg in the earth. Now, frictional force. By definition, we can say that friction results from two surfaces being pressed together closely. It opposes the movement of a motion when two surfaces are close. The friction force often opposes the motion of an object. We can also say that it prevents sliding when we walk. There are at least two types of friction: static and sliding. Third one is applied force. It is a force that is applied to an object by a person or another person. For example, we can say that therapist applying resistance during an exercise. Fourth one is magnetic force. It's act on the body due to an external magnetic field. While magnetic field is not produced by the body's tissue, so it is an external force. Fourth, air resistance force. It is a type of a frictional force that acts upon an object as they travel through air. Air resistance force is often seen to be oppose the motion of an object. This force will frequently be neglected due to its negligible magnitude. For example, we can say skydiver faces this force during skydiving, while runner faces this force during running and a so now, internal force. As compared to the external force, internal force are comparatively less as it generates within the body. So first, muscular force. It is produced by the contraction of muscles. Example, bicep contraction during elbow flexion. It is responsible for movement of the body. Second, ligament force. This force is produced when ligaments are straight. It stabilizes the movement and prevents excessive movement. Third, tendon force. It transmits muscular force from muscle to the bone. It helps to move the joint. Fourth, joint reaction force. Force developed between the articulating joint surface, which results from the muscle contraction. Example, compression at the knee during walking. So, as we have learned about the motion, motion is the change in a position of a body or a body segment over a time. There are three types of motion: general motion, translatory motion and a circular motion. General motion is a combination of a translatory and a circular motion. Example of it are running, walking and swimming. Translatory motion is basically the motion in which all the points of a moving body moves uniformly. It is also called as a linear motion. For example, a patient sliding through a plinth for a treatment. It has two subtypes: rectilinear motion and a curvilinear motion. If a body moves in a straight line, it is known as a rectilinear motion. And if a body moves along a curved path, it is known as a curvilinear motion. For example, a thrown ball moving through the air. Now, circular motion, the motion in which an object is moved around a fixed point. So now, revolution motion. A body moves in a circular path around an external axis or another object. Example, movement of the hand while drawing a circle. Rotatory motion. It is also called as angular motion. A body rotates around its own fixed axis. Example, rotation of a forearm during supination pronation movement. Now, Newton's law of motion. For the force and motion in human body, Newton's law plays a vital role in it. It explains how and why the human body move and walk. There are basically three laws of Newton, as we all know. First, law of inertia. It means body remains at rest or continue to move with a uniform velocity unless acted upon by an external force. The purpose of it is to explain how the body maintains its position at a state of rest or at motion. For example, a runner continues to move forward after crossing the finish line. Second is law of acceleration. It states that the acceleration of a body is directly proportional to the force applied and inversely proportional to its mass. Equation is equal to F is equal to ma, where F is equal to force, m is equal to mass, and a is equal to acceleration. The purpose of the law is to explain the relationship between the force, mass, and acceleration. For example, kicking a football harder makes it move faster. The third, very simple and a basic law, action and reaction law. For every action, there is an equal and opposite reaction. The purpose of it is explain the relationship between the body and its environment. Example, when the foot pushes against the ground pushes back with an equal or an opposite force. So, we can say that this law in human body explains how the body movement, how the body walk, and gait pattern, etc. Thank you.